day to all the dear students. This is chapter number 10, reflection part 2. Students, in this part I have explained you how to use your graph paper for finding reflection of the points in the question given to you of exercise 10b, and I have also explained two very important theories of reflection of point in the specific line. So please study it carefully and solve the questions. Question number 2. Parallelogram ABCD has vertices A minus 3, 2, B 5, 2, C 7 minus 1, D minus 1 minus 1. Determine the image A dash, B dash, C dash and D dash of ABCD under reflection in the x-axis. So we will use our graph. Students, in this video I will explain you how to draw the graphs of your reflection chapter exercise 10b. Now this is the graph paper. So you also have the graph book. You can use your graph book to solve exercise 10b question number 2. This is parallelogram ABCD. It has vertices ABCD whose coordinates are given to us. So let us draw first x and y axis. So use your scale and pencil. First of all, take a midway, or you can take any line as x-axis. So here I am drawing x-axis here using scale and pencil, and in the middle of it, this is the y-axis I am drawing now. So this way you have to construct x and y axis first. Okay, so once we are done with our x and y axis, so let us write the name here. This is y axis here, and this is x axis. So you can see here now I have written here x axis and this is y axis. Okay, so now students, this is the origin where both our lines meet, or you can say both the axes meet. So this is origin. On the right side of the origin there are positive numbers which I am writing with the 1 centimeters gap like this. You can see 1 2 3 4 up to 5 I have written, and on the left hand side of it you can write -1, -2, -3, -4 like this. Similarly, on the upside of the origin 1 2 3 4 5 the positive numbers, and downside negative numbers, as you can see here. So now let us start plotting the points. Point A has coordinate -3 2, -3 2. This is your point A, -3 2. Now the another is point B 5 2. It will lie here 5 2 point 5 2. This is point B 5 2. Point C coordinates are 7 -1. So here let me extend 7 -1. This is point C. Okay, then it will be D point, that is -1 -1. So point D lies here -1 -1. So like this you also can first of all plot the points. Now let me join all the points here so that we will get parallelogram. It is written in the question that you will get parallelogram ABCD. So I am joining this point here now using my scale A to D. Then next is B to C. So here I have already constructed parallelogram ABCD according to the coordinates given to us. Now the question is, determine the image A dash, B dash, C dash and D dash of ABCD respectively under reflection in the x-axis. So students, now let me reflect first point A -3 2 under x-axis. So this is our mirror line x-axis. So the distance from x axis to point A is 2. This distance is 2, you can see. It means downside also it must be 2. And the point lies here. So this is your A dash point, which is coordinates are -3, -2. Next, point B. So here you can see this is point B. 5, 2. Again 2 centimeter means downside also 2 centimeters here. So this is point B dash. Coordinates are 5, -2. This is point C. Coordinates of point C are 7, -1. So if this is the point we want to reflect under x-axis, so we get its reflection here, whose coordinates are 7, 1. This is C dash. And the last point D. D point is -1, -1. And this is x-axis, so its reflection lies here, D dash. It will be -1, 1. So D dash -1, 1. So now you can see I have drawn another parallelogram A dash, B dash, C dash, D dash, which is of reflection points of A, B, C, D under x-axis. So here you can see the image A dash, B dash, C dash, D dash of A, B, C, D. Like this, students, using graph paper, I have denoted A dash, B dash, C dash, D dash with another color sketch pen. You can see you are not asked to join this A dash, B dash, C dash, D dash. So if you just write the reflection points, it is okay, and if you join it, then it is also okay. Exercise 10b, question 3. In this we have two parts. First part, we have to plot some points A, B, C, D given to us in the question, and in the second part also we have to reflect them first in x-axis and then into y-axis. Also second part is very important, which I am explaining you now with using of graph paper. Now taking exercise 10b, question number 3. So in this question we have to plot some points first of all. So already you can see I have drawn x-axis and y-axis. This is our x-axis and this is y-axis. Now first of all we'll plot the points here. They are given 3, 4. So you can give the name here. First of all, this is origin. Then taking 1 centimeter gap, writing here positive numbers and negative numbers here on the left side of origin. Similarly, on the up side, positive numbers, and downside negative numbers. So whenever you start drawing graph, these things you have to remember. Now 3, 4. The first point is 3, 4. I'll give some name first. This is the point 3, 4. Let us take A. A 3, 4. Now the another point is -3, 2. -3, 2. Let me write here B -3, 2, or you can write directly the point, it is okay. Another is C 5, 0. 5 I have to add here. This is point C 5, 0, which lies on the x-axis. Because its y coordinate is 0, it lies on the x-axis. D point -3, -3. Here point D -3, -3. Now after plotting these points, now we are asked to reflect the points first in x-axis and then reflect the points obtained in the y-axis, means double reflection. First of all under x-axis, so this is our mirror line. So this point A first I am reflecting under x. So this distance is 4. So downside also it will be 4, and it is straight line in the point A. So this is our A dash. I write it as A dash 3 - 4 under x-axis. And what happened if I take this point? It is written in the question that plot the point first, then reflect it in under x-axis, and then whatever the point we obtained that point we have to reflect under y-axis. So this is our y-axis. So what is this distance? This is 3 centimeter. So here if I reflect it, so this will be a double dash point. We name it as a double dash minus 3 minus 4. So this is called double reflection. First under x-axis as a dash and then under y-axis as a double dash. Same way students, you have to plot all the points like this. B under x-axis you will get here 2 centimeter. So this is 2 centimeter downside. B dash, this is B dash minus 3 minus 2, and if we reflect this point under y-axis, it will reflect here. The distance is 3. So here also it will be 3 centimeter. B double dash. So B double dash 3 minus 2. This way I have reflected point A first under x and then under y. Similarly, point B under x here as B dash and then this point under y as B double dash. Now, the third point is 5, 0. This is 5, 0. So, I have already explained that if the point lies on the x-axis and it is returned to reflect it in x-axis, then it is invariant point. Means the image of it also the same. Means this is of C or C dash same only, this is the point. But after this, if you reflect under y-axis, it will take here 5, 0. So here it will be minus 5, 0. This is we get C double dash minus 5, 0. So this way students, you can see I have explained you 3 points. The fourth point D, this is the D point 3 minus 3 minus 3. Under x-axis it will go upside here like D dash minus 3 3, and then under y-axis here at the distance 3 centimeter D double dash, it will be 3 minus 3. So this is how the reflection of all the 4 points we have done. So this is the first part of our question number 3 they have asked. Now what happens if you reflect first in the y-axis and then in the x-axis? So now I am explaining B part or the second part of question number 3. What happens if you reflect the first in y-axis and then in x-axis? So this is our point A 3, 4. If I take the reflection in y-axis first, means this is the y-axis. So 3 centimeter distance from the origin. So it will go here this way. This minus 3, 4. And then again in the x-axis. So first A is 3, 4 will become minus 3, 4. And in y-axis. So it will go downside here. Okay. So you see, if you reflect the first in y-axis and then in x-axis, you will get the same point, students. So this way you can check all the points. So you will get the same points as you get here. You see, first I have reflected in x-axis, so I get A dash here, and then reflected here in y-axis. So the same point you will get if you first reflect in y and then in x. The same point A double dash you will find as you found here. This is your A double dash point. So first reflected in x and then in y, or first reflected in y and then in x, you will get the same point. So the second answer of the second question answer is you will get the same points. Okay students, so before I start my exercise 10b, next question, I need to explain you reflection of a point in the line x equal to a. So this is the theory in which there is some line x equal to a and we need to make this line as a mirror line. So this is my axis. I have drawn x and y axis and origin. Now I will draw here one line AB, which is parallel to y axis. You can see here, this is line AB which is parallel to AB. Straight line. Okay. So now this is our mirror line. We are assuming this as a mirror line. And here let us take one point P whose coordinates are x1, y1. Okay, so this point I need to reflect in the mirror line AB. So where it reflect? It will reflect on this side as point P dash. We write here exact distance. This is the distance here. So this is point P dash reflected. Now what we need here, what we are going to derive, we want the points here, the coordinates of these reflecting points, that we are going to find out. Before that, this line AB is line x equal to A. We give the name this line AB as x equal to A. Why? Because this is intersecting x-axis at some point, and this distance must be some A. This whole distance must be A. Why? Because this is our line x equal to A, means the distance is A. Also, you can see this is point P, x1, y1. So, this distance, straight distance from here, this distance will be x1. You can see here the coordinate is x1. So, this much distance is x1. Also, this distance also become same. As you see, this point is reflected in line AB to this side, P dash point. So, this distance and this distance must be same. So, how much is this much distance, students? This is whole A and this is x1. So, this is A minus x1. So, this much distance. So, let me write here some names so that will be more clear to you. Let us take here L, M and N. These are the points I am writing. So, this OB distance is small a, or you can say OM distance is A. LM distance is x1. Why? Because this point P contains x1, y1 coordinates. So, its distance on the x-axis is x1. Now, this much distance, I have written this x1 here, but actually from the origin we have to take the distance. It means this much distance is x1 here. Okay. So now LM distance, this LM distance will be A minus x1. So I write here A minus x1. So these and these are same distances. Why? Because this point P is reflected to P dash. It means this distance is also A minus x1. So students, what I told you, that here this point we want to find out what are the coordinates. So you see y1 will not change, means the y coordinate will not change, it will remain same, because this point, the y distance on the y axis remains same. Only the distance on x axis is changing. So let me take this as x2. So this is x2, y1, the coordinates of P dash. But we want to find the value of x2 now. So how do we find out? That we will find out by taking distance on the x-axis. So here, how much distance it takes? It is taking ON distance. So let me write first LM or OL is equal to x1. OM is equal to small a. You can see OL x1 and OMA. So LM distance is equal to A minus x1 and LM is equal to MN. This both the distances LM and MN are exactly same. Now as I want x2, so I have to find this ON distance total. So for that ON is equal to, you see, OM plus MN. These two line segments, if I add, then I get ON, this total distance. Okay. So what is OM? Already written here A. And what is MN? MN, you can see I have written here A minus x1. So LM is equal to MN, A minus x1. Adding this, we get 2A minus x1. It means what is our x2 point? x2 is equal to 2a minus x1. This is the coordinates I got of this point x2. And as I told you, y coordinate will not change, it will remain same. So how we can represent this reflection? Reflection in the point x is equal to a. This is the line x equal to a, where we have some point xy. So how we represent it? As 2a minus xy. So this is the main thing you have to remember now, that whenever some line is given as x is equal to a, so and some point is given to you, that x coordinate you have to write as 2a minus x. Now you will not understand this thoroughly before I give you one example. So let us take one example to understand it more. See students, here reflection of a point in the line x equal to a means some line will be given to you in exam. So let us take one example here, that let some line x equal to minus 1 is given to you. That x equal to minus 1 is some point you are given here. So now x equal to minus 1 is the line given to you, and I want to find its reflecting. Some point is also given, suppose 2 minus 3. This is the point P given to you, P, and you want to reflect it under this line x equal to minus 1. So as it is written here, you can see. So as this is the example I have taken, in which x equal to minus 1 is the line given to you, and p 2 minus 3 is some point which you want to reflect under this line. So what are the coordinates of this reflected point? 2a minus x, and y coordinate will not change. So what we have, this is our a value. This is our a value. So a is equal to minus 1 given to us here. Now we will find its coordinates as p dash 2a minus x, and y will remain same. Y means this coordinate minus 3. So p dash, the reflected point, 2 into minus 1 here. Instead of a, I substitute here minus 1, minus x. X means this coordinate 2 minus 3. So the answer will be minus 2 minus 2 minus 4 minus 3. So this is what I get as the reflected point's coordinates. Under the line x equal to minus 1, when this point is to be reflected, we get p dash minus 4 minus 3 as our point coordinates. So this theory is basically under the reflection of a point in some line you are given. When some line is given to you, x equal to a, that a value is here, you can see minus 1. Not always negative, it can be sometime positive also. So instead of this a, you substitute that value, and x means that point given to you, that x coordinate you will substitute here. And after solving, whatever the point you get, they are the coordinates of the point given to you. Now let us study about reflection of a point in the line y is equal to b. It means when the line is parallel to x-axis. Students, prior to this, what we have studied, when line is parallel to y-axis means that line will be x equal to a. But now here we have some line which is parallel to x-axis like this. You can say this is my x-axis, y-axis. So this line, some line AB, let us take, whose name is y is equal to b. I write here y is equal to b. This is line AB which is parallel to x-axis now. So in this case, when we want to reflect a point P, suppose here is point P I am taking, whose coordinates are x1, y1. Again, the same thing what we have done with the y-axis parallel line. Now I am doing with x-axis parallel line. So I am taking point here. So where do it reflect under this line AB? It will reflect on that side. You see. So now that point will be somewhere here at the same distance. You see what our basic idea of for a reflection, that whatever the mirror line you have, it will take the same distance. So this is some point P dash which is reflected under line AB, or you can say y is equal to B. Now students, so first of all, how much is this distance? This distance is B. Why? Because it is already given that line AB is drawn from x-axis at a distance B. Now this distance from the origin, that is x1. How much? x1, because our coordinates of P we have taken x1, y1. So how much is this distance now? That will be total B minus x1. This is B, whole distance B, minus I separate this so that I get this much part, B minus x1. So what I told you, that whatever this much distance, the same distance it will cover here. So students, what I need to do now, I want to find the coordinates of this. So you see that here x coordinate remains same. Why? Because you see it has same line. This is the x coordinate, means on the x-axis how much distance it cover. So x1 remains same, x coordinate remains same. Where the change will become in y coordinate. You see, this is the y coordinate, it will come here. So it become y2. Let it be y2. And then we will find what is the value of y2 here. So now, for that, let me give some names here. Suppose this is some, I am drawing here straight line, and this also a straight line. So this is some point L, this is M, and this is N. Okay, so L, M, N, you can see now I am writing here what is our OL distance. This is our OL, this is OM. So OM distance is B. Already you can see OM distance is B. Then OL distance means this much. OL is equal to x1, and LM is equal to B minus x1. Also LM and MN are same. LM is equal to MN. So now this distance is also B minus x1. What we need? We need this y2. For that we need to find this whole ON distance. So ON is equal to OM plus MN. OM plus MN, and OM you can see that is B, and MN is same as LM, B minus x1. It means 2B minus x1. This is our ON value, means our y2. You see what is our y2 value now? We found here that I am writing reflection of line y is equal to B as point xy will become, x remains same, the change will be here in y. So this is 2b minus x. This is actually, this is not x1 students, I have made some mistake. You see this is y1 on the y-axis though. So actually this is y1, this is also y1. Okay, so let me change here also y1, y1. Okay, so now you also take care while you solve, because it is not on the x-axis, it cut the distance on the y-axis. It is 2b minus y. Now let us take one example here. For example, let y is equal to 3. Some line is given to you in the question. So, and one point also will be given to you in the question, that let some point, that is P15. This is the point given to you, and you want to reflect under this line y is equal to 3. So how do you reflect? For that, first of all, you want P dash x 2b minus y. Now what is b here? So B means this 3. This is your B value, which is given as y is equal to B. And x is same here, 1. There is no difference in the x coordinate. 2. B is 3, so I multiply 2 with 3 minus y is this 5. So now I get P dash 1, 3 2s are 6 minus 5, that is P dash 1 1. So this is the coordinates of the reflected point of the line y is equal to 3. This is the point and this is the mirror line y is equal to 3. So what is the reflection point we get? P dash 1 1. So how we are using this theory to get our reflection point coordinates, so that you have to understand.